Hello, everyone, and welcome to this short demo on how to fetch and analyze COVID-19 tweets using SFU's own DataPrep library. Uh, this was also an assignment for CMPD 456, and the problem statement for those who are not aware of the assignment was to fetch a random 1,000 tweets from Twitter, then plot the frequency distribution. So how many times the word appears in those 1,000 tweets, then the word cloud and other statistical analysis, and then repeat the same for 1,000 tweets with the word COVID-19 in them. So for the students of CMP 456, as you all know, the solution was about 150 lines to 200 lines of code, right? In this demo, we're going to show you how you can achieve the same using DataPrep in less than 10 lines. So let's get started. So the first thing would be, if you don't have DataPrep installed, you'll just uncomment this line and run this cell. I have it installed, so I won't be running this. So after you have the DataPrep installed, you can come to this and we'll import the connector class. So how do we do that? We say from dataprep.dataConnector, import the connector class. So let's run that. The next thing would be to obtain access token from the Twitter API. We have given a step-by-step instructions on how this can be obtained on this link. So if you go on this link, it shows you how to obtain the Twitter API. Once you have those, you'll fill in your client ID and a client secret here and run this cell. And once we have that, we'll instantiate a DC object using this. So DC equals connector. Then a connector's name in DataPrep is called Twitter, so Twitter. And then authentication is a key value pair. So client ID will be the client ID that we enter here, and the client secret would be the client secret we enter here. So let's run this cell now. So we have a DC object. Now let's run an info on this object and see what does it have. So it has a table tweets and it takes parameters, right? So Q is a required parameter. This is a query parameter. The two other parameters are optional, count and max ID. And also you can see sample methods that you can run on a connector object. That's query and show schema. So let's show schema for our tweets table, right? So we got this tweets table. So let's run this and let's see what the schema is. So the schema is we have 6 columns. Those are created at, text, truncated, ISO code, hashtags, and ID. The one we are primarily interested are text and ISO code. So the next thing would be the real work, fetching tweets from the connector and using our keyword, right? So how do we do that? And before we do that, the object that this query returns is a data frame. Data frame that has these columns as columns, right? So having a data frame would significantly make our life easier, right? Because it's very easy to work with data frames. So now let's see how to fetch that. So we say dc.query. A table name is tweets. So we put tweets. Then Q is equals to COVID-19, right? And then the count is 1,000. It can be like 100. It can be 1,500. It can be 2,000. We don't have to worry about the number because Data Connector takes care of pagination. So we don't have to worry. To get random tweets, we'll replace this by just the word false. But since we're getting COVID-19 tweets, we'll revert this back to COVID-19. So let's run this cell and see how long it takes. So as you can see, it just takes like 3 or 4 seconds to fetch 1,000 tweets, right? That's pretty impressive. Now let's run the head object in this and see what do we have here. So we have this data frame that has 1,000 rows. And as you can see, we have the text column that has all the tweet words, right? Then created at ID, truncated, hashtags, and the ISO language. So we are only interested in the English language codes, right? So we see here's a Spanish language code, so we don't want that. So we'll filter the tweets based on just English language. So we say df is equals to df, where the code is equals to en. And we reset the index. This we do for our analysis part. That's going to be crucial. And we show that in the next part. So let's run this. Now let's run ahead again. And we see the Spanish ES is not there. We have all English language tweets now. Now the fun part comes, analysis, right? With DataPrep. And you'll see how easy it is using DataPrep to get all the relevant information. So again, we want to analyze the text column, right? And how many times a word has appeared, what is the frequency, what the word cloud looks like, okay? So we'll import the plot from dataprep.eda module. So let's do that. And now, using this plot, the first parameter is our data frame object. So data frame is called df, so we'll put df here. And then the column name is a string, so it's called text, right? So we have put text here. Let's run this and see what do we get back. So we've gotten this back, right? So there are 412 distinct tweets. The mean length of the tweets is 130 characters, right? Let's go to the word cloud. So as we expected, COVID-19 is the most common word, right? Then there's doctors, cases. Let's look at the word frequency. So COVID-19 appears 464 times, and it has a probability of about 6%, right? Then we can see the length, so we can see the distribution. So about 75% of the tweets fall between the lengths of 135 and 148. Again, this information is out there. And we got all of this using just one line of code, right? We don't have to write our own functions, import multiple libraries, nothing. We just have that in one line of code. And this is all the code you need to get the random and the COVID-19 tweet. So let's run this again and see. And let's plot this. So this is for the COVID. So again, we expect COVID to be the most common name, right? Now let's fetch random tweets and let's plot the random tweets out. So let's go to the word cloud and see what the random tweets are. So we see the word false is pretty common. HTTPS is pretty common. Google is pretty common. Even the word frequency, false is the highest one, right? Then it's HTTPS. The mean length. So you can see how powerful this library can be to analyze text data, and not only just text data, it also works on numerical data as well. So if you have a different data frame and there's some new numbers and you want to analyze those numbers, it can also do that for you. Now let's come to a bonus example, right? So let's analyze publications for Professor Jianpei. And our problem statement is to find out the most common areas of research for Dr. Pei, right? So Data Connector has another connector called DBLP. And this connector is basically to fetch the publications from research associates, professors, and other research related people, right? So all the publications are stored in this DBLP, right? So again, we import the connector object. Like we don't have to do it, we don't have to import again, but we have done it here. So, and then we instantiate the DC object using connector, and then we just specify DBLP because the DBLP connector does not take in any authentication, right? And then we run a query on the publication table and we specify the first name, that's Jian, the last name is Pei, and then we want 1,000 publications from Dr. Jian Pei. So let's run this. Again, it just took 2 seconds for us to collect 1,000 publications from Dr. Jian Pei. Now let's run the columns and see what do we have in our data frame. So we have authors, titles, venues, pages, publications, URL, right? The one we are interested in is title because usually title has some keywords, right? So we are interested in that. So let's analyze that. So we use the plot, then our data frame, that's this data frame, DBLP. And the column name is title. So let's analyze this. Awesome. So we see, first we get the numerical statistical analysis, like what's going on. So we know that the mean length of the title is about 65 characters, right? Now let's see the most common areas. Okay, so it's mining and data, right? As expected. So let's look at the word frequency. Both mining and data appear 117 times. It also indicates that these two words are used together, data mining, right? Length, again, it shows the distribution of titles. So we see majority of title falls here, right? And so on. So as you can see, this is an awesome library to analyze basically anything like text data, numerical data, like just using a few lines of code, you can analyze and make sense of like what is happening with the data, how the column is behaving, what the values are. Um, and if you want to learn more about this library, and I highly encourage everyone watching this to download DataPrep. And if you want to have a look at the documents and examples, you can go onto this page. This is our GitHub page for the DataPrep. And it shows you, in the README, it shows you a few examples on numerical data sets. And also, if you want to contribute to this project, there's excellent, and if you find a bug, right, in the project, and if you want to contribute, there's documentations on how to contribute as well. So again, like you saw how easy it was to analyze, fetch 1,000 tweets and then analyze and then make sense out of those tweets, right? And I hope you had a great time. And thank you everybody, and have a great day.